Hi everybody, Mrs. Pesic here. We are looking at the Chapter 10 practice test, and I'm going to try and go through these with some explanation as quickly as I can. For number one, you are to find the values of the 6 trig functions of theta. These 3 sides were already drawn in for you, and notice here's theta over here. So this is the angle we're talking about. We want the sine of that angle, the cosine of that angle, the tangent of that angle, and so on. So you know from Secant that the sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. So for the sine of theta, we take the opposite side, which is 9, over the hypotenuse, which is 41, and we get 9 over 41. For the cosine of that angle, we would want to take the adjacent side, 40 is the adjacent side, over the hypotenuse, this is CAH, and that's going to be 40 over 41, and the tangent is going to be the opposite side over the adjacent side, so that's 9 over 40. Then to get the other 3 trig functions, you do need to remember that sine and cosecant are reciprocals of each other. So we just have to flip 9 over 41 and we get 41 over 9 as the cosecant. Then we know that the cosine and the secant are reciprocals of each other. So 40 over 41 was the cosine, so 41 over 40 is the secant. Tangent and cotangent are reciprocals, so if tangent's 9 over 40, cotangent is going to be 40 over 9. Let's take a look at number 2. For number 2, you are not given all 3 sides. You were only given that this side here was 2. That was the adjacent side to our angle theta, and that the opposite side was square root of 5. And so you did have to do Pythagorean theorem, so we're going to take 2 squared plus square root of 5 squared, and that's going to be equal to c squared, because c is our hypotenuse here. It's the side opposite the right angle. 2 squared is 4, square root of 5 squared is 5, so we end up getting 9 equals c squared, and so c is equal to 3. So that's why I wrote in 3 here, and now the process is the same. Here's our angle theta up top, so this side is going to be your opposite side, this side is going to be your adjacent side, and this side, as always, since it's across from the right angle, is your hypotenuse. So sine is going to be square root of 5 over 3, opposite over hypotenuse. Cosine, again I'm using Secant. Cosine is going to be the adjacent over the hypotenuse, so that's 2 over 3. And the tangent is opposite over adjacent, so that's square root of 5 over 2. Now to get the cosecant, we need to flip the square root of 5 over 3. We're going to write 3 over square root of 5, but we don't like leaving radicals in the denominator, so we multiply by square root of 5 over square root of 5, and we get this. The reciprocal of 2/3 is our secant, so that's 3 halves, and we flip square root of 5 over 2 to get 2 over square root of 5, multiply by square root of 5 over square root of 5, and we get our cotangent as 2 rad 5 over 5. Let's take a look at number 3. For number 3, you could use special right triangles. This is going to be a 45-45 right triangle, and if 5 is s, then this side would also be 5, and this side would be s times the square root of 2. So your answer is just going to be 5 times the square root of 2. If you don't remember your special right triangles from geometry, you can use trigonometry here, because we know if this angle is 45 and this opposite side is 5 and we're trying to find the hypotenuse, that involves sine. So the sine of 45 is going to be 5 over x, opposite over hypotenuse. And we think of this as sine of 45 over 1, and then we can just cross multiply. So we get x times sine of 45 equals 5 times 1. We get this equation right here, and we divide both sides by the sine of 45 degrees to get this equation, and that turns out to be approximately 7.07, which I'm going to bet is the same as 5 rad 2. Let's take a look at the next problem. For number 4, you are trying to find x here. This time we must use trigonometry. This angle is 22. We're trying to find the adjacent side, but we do know the hypotenuse. Which trig function in Secant involves adjacent and hypotenuse? That's the cosine. So we take cosine of 22 is going to equal adjacent over hypotenuse. That's x over 41. Think of this cosine of 22 degrees as being over 1 and cross multiply. Take 41 times cosine of 22 degrees equals x times 1. And that brings up this equation right here. And then we just get our calculator out and we get 41 times cosine of 22 degrees is 38.01. Let's take a look at number 5. For number 5, we need to find the side x. We're given this angle here is 36, and we know that the opposite side from that angle is 12, and we see that we're trying to find the adjacent leg, right? We don't really care about the hypotenuse in this one, so that brings up the TOA part of SOHCAHTOA, opposite over adjacent. So we say tangent of 36 equals the opposite side over the adjacent side. So we get tangent of 36 equals 12 over x. Think of that tangent of 36 degrees as being over 1. Cross multiply, and you end up getting x times tangent of 36 equals 12. Divide both sides by tangent of 36 degrees, and you end up getting 16.5. Let's take a look at the next one. A biologist's eye level is 5.5 feet above the ground. She measures the angle of elevation to an eagle's nest on a cliff to be 66 degrees when she stands 50 feet from the cliff's base. To the nearest foot, what is the height of the eagle's nest? Well, here's my sketch, and I am no artist, but here is the biologist standing right here, and her eye level is 5.5 feet above the ground, and when it says her angle of elevation is 66, angles of elevation always have to start with horizontal. So from a horizontal and looking up like this, that's 66 degrees. All right, we can see the nest. My crudely drawn nest is up here, and so she is trying to figure out how high up that nest is. Well, I do want you to remember she's 50 feet away from the base of this cliff, so this is 50 from here to here. And we know that from here to here is 5.5. That's the same as her eye level height. And what we can do, though, is we can picture just this triangle right here, which is a right triangle, and we know the adjacent side to the 66 is 50, and the opposite side is what we're trying to find, x. That sets up a tangent situation from SOHCAHTOA. So the tangent of 66 degrees equals x over 50. You do the math on this, cross multiply, and you get x equals 50 times tangent of 66 degrees, which brings up x equaling 112.3 feet. But that's not the entire height of the nest, because you had to add that 112.3 feet to the 5.5 feet here. So the entire height of the nest is all this way here, and that turns out to be 117.8. All right, let's take a look at number 7. This one says draw an angle. Draw an angle with the given measure in standard position. If you're trying to draw negative 350, that is a negative angle. So you are going to start off by always your initial side. Start drawing your right side of your x-axis as your initial side. Since we have a negative angle, that means we want to go in a clockwise direction. How far do we want to go? Well, if I go this far, that's 180. I need to go further than that. This far would be negative 270. We need to go further than that. So I'm going to have to go almost all the way around. If I did go all the way around, that would be 360. That's too far. So here's our angle that represents negative 350. If we're drawing an angle that measures 420 degrees, again, whether it's positive or negative, it has an initial side here on the positive part of the x-axis. It's a positive angle, so we are going to be going in a counterclockwise direction. That would be a 90-degree angle. That's 180. That's 270. That's 360 right there. We need to go farther than that, but not all the way to 450. So I don't want to go that far. I want to go past 360, though, and end up about here. And so that is how I would indicate my angle that measures about 420 degrees. All right, let's take a look at the next one. This is number 8. find the measures of a positive angle and a negative angle that are coterminal with each given angle. So if it's 510 degrees and you want to find coterminals, just add and subtract multiples of 360. So if I subtract 360, I end up getting a 150-degree angle. So 510 degrees and 150 degrees are coterminal. But I needed to find a positive and a negative. So to do that, I'm going to have to actually subtract 360 again to get into negative territory. And so my two answers could be negative 210 degrees and a positive 150 degrees. Likewise, with negative 805, if I add 360 to that, I will actually get negative 445 degrees, which is great. That would be a negative coterminal angle. If I subtract 360, if I add 360 again, I end up getting, I need to do subtraction here, 4, 8, 85. So I end up getting 85 degrees, but it's still negative. So I could list this angle or this angle, either one, as my negative angle, but I still have to find a positive angle. So I'm going to add 360 one more time, and I end up getting 275 degrees. So I would list this or this as my negative, and I would list this one as my positive. All right, let's take a look at number 9. For number 9, it says 3, negative 6 is a point on the terminal side of theta in standard position. Draw a triangle on the coordinate plane that represents the situation. Then find the exact value of the 6 trig functions of theta. All right, so all of this starts off with a good sketch. If you're not drawing a good sketch, that is going to be a problem. So here we want to draw 3, negative 6. So I find that point is right about here, and I start off by going from the origin to that point. That's my terminal side of my angle, and this is my initial side of my angle. All right, technically the angle would look like this, but it's going to have a similar angle measure right here at theta. So what I'm going to do is I'm going to go from that point, which was 3, negative 6, and I'm going to go vertical until I get to the x-axis. Whether my point is below the x-axis like here or above, I still draw a vertical line to get to the x-axis. That's my straight, my vertical angle here. That's a right angle, I should say. So this is 3, this is negative 6, and we need to find the length of the hypotenuse. You know Pythagorean theorem, so it's going to be 3 squared, well, square root of 3 squared plus negative 6 squared. That turns out to be 9 plus 36, and that is square root of 45. But we don't leave it as square root of 45. We can simplify that. Square root of 9 times square root of 5, or better yet, 3 times the square root of 5. So that's how we are going to write in this length right here. This is 3 times the square root of 5. And the rest is just like problem number 1 or 2 on this practice test, where you just have to find sine of theta, cosine of theta, tangent of theta, and so on. All right, so that's all written here. So if I want the sine, let's start with sine. Sine of angle theta, it's going to be the opposite side, which is negative 6, over the hypotenuse, which is 3 rad 5. I have that written right here. And then I had to rationalize the denominator. That means get rid of the radical. So I multiplied by square root of 5 over square root of 5, and I get negative 6 rad 5 over 15. How did I get 15? 3 times square root of 5 times square root of 5 is 3 times square root of 25. That's 3 times 5 is 15. And then the 6 and the 15 divided or reduced to negative 2 over 5. So I get negative 2 rad 5 over 5. To find the cosecant, by the way, before we go on to anything else, I would just want the reciprocal of sine, but I would actually flip it from this original one. That way I don't have to rationalize again. So I will just have 3 rad 5 over a negative 6, reduce the 3 and the 6, and I get the cosecant as negative rad 5 over 2. All right. Likewise with cosine. Cosine, I want to take the adjacent over the hypotenuse, so that's going to be 3 over 3 rad 5. I divide out the 3's and I get 1 over rad 5. Multiply by rad 5 over rad 5, and I get square root of 5 over 5. The reciprocal is secant. So to get the secant, I would actually just flip what I have here, and that would be 3 rad 5 over 3, if you can see that, and then the 3's divide out, and I'm just left with rad 5. Tangent is even easier, because then I just want the opposite side over the adjacent side. So that's just negative 6 over 3, which is negative 2. And cotangent is the reciprocal. That's 3 over negative 6, which is negative 1/2. Let's go on to the next problem. Number 11. Oh, by the way, we're skipping number 10, so don't worry about number 10. Number 11, you're converting each from degrees to radians or radians to degrees. And we do not want decimals. All right, we want an answer in terms of pi for 11 and 12. And we want, well, I guess decimals are okay for 13 and 14. So for number 11, you take negative 140 to convert it to radians. You're going to multiply by pi over 180. So 20 goes into 140 7 times, 20 goes into 180 9 times. So I'm left with negative 7 pi over 9. And for number 12, again, we're going to multiply by pi over 180. So if I take 36 times pi over 180, the 36 goes into 36 once and into 185 times. So I end up getting pi over 5. For number 13, since I'm going from radians to degrees now, I would multiply by 180 over pi. So I did 3 pi times 180 over 8 pi. That gives me, the pi's divide out, and I'm left with 135 over 2, or 67.5 degrees. And then negative 10 pi over 3, multiplied by 180. That's supposed to be a 180 over pi. Again, the pi's divide out, and you're left with well, and I can divide out 3 goes into 3 once, and into 180 60 times, so I end up getting negative 10 times 60, which is negative 600 degrees. Let's look at the next problem. For number 15, 16, 17, and 18, you do need to be looking at your unit circle. So to find the exact value of the trig function, hint, if the angle is not on the unit circle, find a coterminal angle that is on your unit circle. So for number 15, the sine of 210 degrees. Here's 210 degrees, starts out here and goes like this. All right, you look on your unit circle and you see at 210 degrees, the ordered pair is negative square root of 3 over 2, comma, negative 1/2. Sine is the y coordinate. So we're really looking at negative 1/2 as our answer. All right, for number 16, it says tangent of negative 120. You don't have negative 120 on your unit circle, so find a coterminal angle with negative 120. So add 360 to that, and you end up getting 240 degrees. That means that the tangent of negative 120 degrees is going to be exactly equal to the tangent of 240 degrees. Now, if you look at your unit circle, tangent of 240 is right here, where the ordered pair is negative 1/2, negative square root of 3 over 2. So remember, tangent, very important, tangent is y over x. So I need to take my y coordinate divided by my x coordinate. So I get negative square root of 3 over 2 divided by negative 1/2. That's the same as negative square root of 3 over 2 times 2 over negative 1. 2's divide out. The ones, negative over negative is positive, and I end up getting just square root of 3 as my answer. All right, for cosine of pi over 2, you find pi over 2 on your unit circle. That's straight up where the ordered pair is 0, 1. Cosine is the x coordinate, so we just need that x coordinate, which is 0. For tangent of 19 pi over 4, again, 19 pi over 4, too big to be on the unit circle, so you could actually add or subtract multiples of 360 to get it on the unit circle if it was degrees, but since it's radians, I actually need to subtract 2 pi. You could always convert that to degrees first and then add 360 or subtract multiples of 360. I just chose to keep it in radians. So I did 19 pi over 4 minus 2 pi. 2 pi is the same as 8 pi over 4. I got a common denominator now, so I can subtract, and 19 pi over 4 minus 8 pi over 4 is 11 pi over 4. Unfortunately, that's still not on our unit circle, still too big, so we are going to subtract another 2 pi, or you could say 19 pi over 4, my original minus 4 pi. So that's 19 pi over 4 which is going to be minus 16 pi over 4, and that gives me 3 pi over 4. Bottom line is that the tangent of 19 pi over 4 is equal to the tangent of 3 pi over 4. 3 pi over 4 is found here on your unit circle, where the ordered pair is negative square root of 2 over 2, comma, positive square root of 2 over 2. Remember, I want the y over the x, so that's going to be square root of 2 over 2 over a negative square root of 2 over 2, which turns out to equal negative 1. Let's look at the next problem. On this one, it says, a railing along an observation deck at an aquarium has a length of 22 feet. The railing is shaped like an arc that represents 1/8 of a circle. 1/8 of a circle would be 1/8 of 360 degrees, which would be 45 degrees. So that's your answer for part A. But I also did convert that to radians. If I multiply by pi over 180, I get pi over 4 radians. For part B, it says to the nearest foot, what is the radius of the circle on which the railing is based? So we have this little railing here that's actually part of a circle, a larger circle. But we know that the angle here was 45 degrees, or pi over 4. And we're trying to find, if this is 22, we're trying to find the radius of that circle. We use this formula, S equals R times theta, which you could visualize in the little triangle method, like on the video, S over R theta, drawn like that. And so that means that we would want to plug in S, which is arc, S represents arc length. All right, R represents radius, and theta is the angle measure in radians. Must be in radians, very important. So I'm going to plug in what I know. I know this is 22. I don't know R, and I know that theta in radians is pi over 4. So to solve for R, I'm just going to take 22 and divide by pi over 4, and on my calculator, that turns out to be just about 28 feet. So that is the radius right there. All right, let's take a look at number 20. For number 20, it says find all possible values of sine inverse of square root of 3 over 2. And that means on your unit circle, where are all the places on the unit circle where your y coordinate is square root of 3 over 2. So you're trying to find the angle where the sine is equal to square root of 3 over 2. On our unit circle, I think you'll see that that occurs at 2 places, 2 pi over 3 and at 4 pi over 3. 2 pi over 3 has an ordered pair of 1/2, comma, square root of 3 over 2. And 4 pi over 3 has an ordered pair of negative 1/2, comma, square root of 3 over 2. But both y coordinates are square root of 3 over 2, so that's why we list those as our answer, 2 pi over 3 and, why did I say 4 pi over 3? My humblest apologies, I'm messing up this problem. I drew them right, I wrote the wrong angles. My humblest apologies. This should be pi over 3 and 2 pi over 3. So I wrote my ordered pairs correctly, I just wrote my radian measures incorrectly. So that's why we have pi over 3 and 2 pi over 3 as 2 possible values. We could keep going around the unit circle. We get 7 pi over 3, 8 pi over 3, and so on. For number 21, find all possible values of cosine of negative, my bad, again, another error, this one on me for typing this. This should have been cosine inverse of negative square root of 2 over 2. That means find the angle whose cosine is negative square root of 2 over 2. So on our unit circle, that occurs here at 3 pi over 4, which is right here, and at 5 pi over 4, which is right here. 3 pi over 4 has the order pair negative square root of 2 over 2, positive square root of 2 over 2. And 5 pi over 4 has the order pair negative square root of 2 over 2, negative square root of 2 over 2. Bottom line, we're looking for where's the x, because cosine is the x coordinate. Where's the x coordinate? Negative square root of 2 over 2. So with that in mind, we would list 3 pi over 4 and 5 pi over 4. Let's go on to the next problem. For number 22, 23, and 24, the directions say give a translation for what is meant by the following and then evaluate. If you see a capital S in the sine inverse of 1/2, you're only going to have one answer possible, not 2 or 3 like in the previous problems. So the translation for this, what does that mean? It means the angle between negative pi over 2 and pi over 2 that has a sine value of 1/2. So if I'm only looking on the right half of the unit circle, why don't you right now go to your unit circle. Let's make up a unit circle right here. If you have not already done this on your unit circle to help you, we're only interested in going from negative pi over 2 to pi over 2. But I know on your unit circle, you probably don't have negative pi over 2 written here. You have 3 pi over 2. But that's because we're going this direction. But we don't want to go that direction. We want to go this direction. So what I'm going to ask you to do right now is not cross off the 3 pi over 2, but actually add on, right next to it, the negative pi over 2. Likewise, right here, this is, you got it written as 11 pi over 6. That's if you go around this way. But what if I go around, if I just go in a negative direction? Well, 11 pi over 6 one way, or negative pi over 6 the other way. And here you have a 7 pi over 4, but that's the same as a negative pi over 4. And here, down here, we have a, 5 pi over 3, but that's the same as a negative pi over 3. 5 pi over 3 goes around this way, and coterminal with that would be this direction. That would be negative pi over 3. All right, so back to this problem. So translation is here, the angle between negative pi over 2 and pi over 2 that has a sine value of 1/2, and that occurs right here at pi over 6, where the ordered pair is square root of 3 over 2 comma 1/2. Again, we're looking for the y coordinate to be 1/2. So it occurs at pi over 6, and that's our one and only answer. What about 23? It says capital cosine inverse of negative square root of 3 over 2. That means the angle between 0 and pi this time. All right, not negative pi over 2 and pi over 2, but 0 and pi, that has a cosine value of negative square root of 3 over 2. So that occurs here on our unit circle. Remember, we're only looking at the top half. That occurs here at 5 pi over 6. 5 pi over 6, which has the ordered pair negative square root of 3 over 2, comma 1/2. All right, again, we're looking for where on the unit circles the cosine negative square root of 3 over 2, and that's just 5 pi over 6 if we're only looking between 0 and pi. Capital tangent inverse of negative 1. Translation, the angle between negative pi over 2 and pi over 2, so that's the same as here with sine. So sine, capital sine inverse and capital tangent inverse both have the negative pi over 2 to pi over 2. The angle between negative pi over 2 and pi over 2 that has a tangent value of negative 1. So that is going to occur here on our unit circle. But remember, we're not going to write 7 pi over 4. That would be an incorrect answer because 7 pi over 4 is not between negative pi over 2 and pi over 2. That would be wrapping around this way, and we don't want to wrap around that way. We want to just go this direction. So the answer is negative pi over 4. Why is it negative pi over 4? Because that's where the ordered pair is square root of 2 over 2. Negative square root of 2 over 2, and the y over the x is going to be negative 1. All right, so let's take a look at number 25. Here you are given this problem. A driver uses a ramp when unloading supplies from his delivery truck. The ramp is 10 feet long, and the bed of the truck is 4 feet off the ground. To the nearest degree, what angle does the ramp make with the ground? Draw a sketch. So here's my truck. It's not a very good looking truck, but there it is, and this distance right here is 4 feet. So the bed of the truck right here is 4 feet off the ground. We know that the ramp itself is 10, and we're wondering about this angle that the ramp makes with the ground. So that brings up a sine situation because we know the opposite side and we know the hypotenuse. So the sine of theta is 4 over 10, but that means that theta is the angle whose sine is 4/10. So we have to find that out by doing theta equaling sine inverse of 4/10. On our calculator, if you're in radian mode, you get 0.4115 radians, and I multiply that by 180 and divide by pi, and I get 23.58, or approximately 24 degrees. All right, now we get into some problems using law of sines and law of cosines. For this one, it says find the area of the triangle, round to the nearest tenth. We have this formula for the area of a triangle. We would use this if we were given a side angle side situation like we are here. Side angle side. So it's 1/2 one side times the other side times the sine of the included angle. 1/2 BC times sine of A. When we work all that out on the calculator, we get 3.9 square feet. Let's take a look at the next example. For this one, solve the triangle, round to the nearest tenth. In this case, you were given a angle, side, angle situation like this. Angle, side, angle. And so in order to do this, we can figure out the remaining angle. Just take 180 minus your first two angles. So 180 minus 50 minus 78 leaves 52 degrees for our third angle. Now we're in business with the law of sines. Remember, law of sines says sine of angle A over side A equals sine of angle B over side B. And that's also equal to the sine of angle C over side C. So in this case, we would take sine of 52 degrees over 15 equals sine of 78 degrees over R. Cross multiply like we did earlier, and we end up getting R equaling 15 times the sine of 78 over the sine of 52. That turns out, don't forget to use the degree symbols on your calculator, that turns out to be about 18.6. All right, now that we know that side, we have one more side to find, and that's Q. That's this side here. So we set up law of sines again. I went back to the sine of 52 over 15 equals sine of 50 now over Q. And when we work that out, we get 14.6. All right, and these are all in meters. All right, let's take a look at number 28. For number 28, it says draw a sketch, solve the triangle. In this case, we are given an SSA situation, which is also something we can handle with law of sines. So we do sine of 130, that's this angle, over the side opposite that, which is 7, equals sine of angle B over the side opposite that. When we set that up, we end up getting sine of angle B equals 3.5 times sine of 130 degrees over 7. My calculator's in radian. I'm sorry, I don't need radians yet. So I get 0.383 as the sine of B, but I'm trying to find angle B, which means B is the angle whose sine is 0.383. Now I need the sine inverse, and when I do that, I got 0.39307. That's radians, but I had to convert that, so I multiply it by 180, divide by pi, and I end up getting 22.5 degrees. I can find my third angle by taking 180 minus 130 minus this 22.5 for this angle, and I end up getting 27.5 for this angle. Now I need to do law of sines one more time, and I didn't finish this one, I'm sorry to say. So I'll let you finish this one up to get C.
End this school day, I do have a few announcements.
All right, I'm going to stop this video at this time, and I hope that that was enough of a help. I didn't really get to all of it, but I hope that if you take a look at the solutions on my website, you'll be able to figure out the remaining problems. All right, have a good day, and we'll see you for the test.
It's at 7 o'clock here.